statement in our first reason. Given every single time. Those are your freebies. So we're going to say AD is an altitude. I'm going to abbreviate. Of triangle ABC. And AD is congruent to CD. And that's given. Okay, 2 points right there. What's our very last statement every single time? What you're trying to prove. And we're trying to prove that triangle ABD is congruent to triangle CBD. And with these triangle proofs, I like to look at my given information first. If they're stating that two things are congruent in your given, make sure you mark them. Okay? If it's not already marked for you. So we have to mark that AD is congruent to CD. Marked. So we took care of that bit of given information. Now we're going to look at this other bit. Do we have a vocab word in that given information? Yeah, altitude. So what's our very next reason going to be? Good. Definition of an altitude. Then start thinking, what do we know about altitudes? We know they drop straight down and they create what kind of angles? Right angle. So we know angle BDC is a right angle. I'm going to state that. And we also know if BDC is a right angle, what else also has to be a right angle? Yeah, ADB. BDC. And again, make sure we go in order. BDA also has to be a right angle. I'm going to mark that. Well, what do we know about right angles? What do they equal? 90 degrees. So if every single right angle equals 90, we can say that all of them are congruent to each other. So your very next statement is going to be angle BDC is congruent to angle BDA because all right angles are congruent. They're all 90. No, you have to, I know that's a vocab word. But the proper reason is all right angles are congruent. Because the definition of a right angle doesn't say that it's congruent to another angle. So it wouldn't really match that statement. These two go hand in hand. So if you have altitude, you know you're going to be stating that these two angles are right angles every time. And then your very next reason after that is to state that they're congruent, and your reasons all right angles are congruent. That's true with any type of line that makes right angles. So perpendicular lines, perpendicular bisectors, things like that. Same kind of stuff. So we dealt with all of our given information. Once you've dealt with the given information, look and see what type of triangles are these. What are they sharing? Yeah, they're sharing a side. And what did we say yesterday? Our reason is every single time when they're sharing a side. What did we say yesterday? Like looking in a mirror. Yeah, reflexive. So that every time they're sharing a side, we know that shared side is congruent to itself. So we say our reason's reflexive property. And we just state that BD is congruent to BD. And then look and see what three pieces did we mark. We marked a side, reason, angle, then we mark the side. Side and angle, then a side. So what's our reason for stating that these triangles are congruent? Angle, side. Those are the three pieces that we have. So, questions over that?
All right, well, you can do the practice at a later time and date to get that additional help on this and then answer any questions you have. We're now going to go on to the next section of notes, though. So flip it over your page. Find it towards the middle bottom there. You'll see it down there. So we're going to add more tools to your tool belt. Before, you guys had SSS, and you had SAS. Now we're going to get two new ones. ASA, which I'm sure you guys can piece together, is angle, side, angle. And the other one is AAS, angle, angle, side. So, before we get into this, we need to talk about some pieces. Last time we did SAS, we talked about included angle. An included angle means it's an angle between two sides. Now we have this idea of an included side. It's the reverse of that. It's a side formed by two angles of the triangles. So it's a side that's between two angles. So let's look at the example up here. You can tell me which side would be the included side. Angle R. Angle R is sitting right here. The next one says angle T. Angle T right there. What side is between angle R and angle T? What is it? RT, yeah, that's it. RT is the side that's in between there. This is the side that's sitting in between there. So we would say that RT is the included side. I think you're saying side. I'll say P. Very tempting to say P, but P's an angle over there, so I can't have that. So it's got to be between there if we want to call this angle, side, angle. And again, you'll get more practice with this. It's just working your way around the piece. So there's three sides there. I would go angle, side, angle. Because I start at an angle, go to side, go to angle. That's how it works. All right. Let's talk about this one down here, what they are. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So it's another shortcut we have. If we've got two angles and there's a side in between those two angles, matches up with another triangle at the same locations, that is it. Angle, side, angle. The next one, you can piece it together. You can see where the location of the side is. So this next one is angle, angle, side. If two angles and a non-included side, non-included side of one triangle are congruent to corresponding two angles and the side of the second triangle, then the triangles are congruent. So if I'm working my way around the triangle, I've got an angle, then a side. They would be congruent if it matches up with another one. So those are the shortcuts you have. You had side, 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 angle, side, angle, side, angle, and angle, angle, side. If you notice, there's other combinations you can do with those letters. Some don't work out. This example right here. We have side, 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 but what don't we have? We haven't used yet. We had side, side, side. What's the opposite of side, side, side? Triple A, right? A, angle, angle, angle. I'll tell you this, you can't call it triple A. Triple A is Automotive Association of America. It's called if your car breaks down or something like that. Can't call them this situation. Doesn't work out. We'll explain why that works out here in a second. Is there any other combinations you guys can think of? The letters A and S together? Possibly, but I don't know if we're allowed to talk about that guy. So, yes, that is another one you have, but we're in school, so we can't talk about that. But we're going to say at sign, money sign, money sign. Because you guys can spell in your head, I appreciate that. I know you can. Oh, you spelled a silly word up here. Can't do that. It doesn't work out. If that angle was in between those two S's, that would work out. SAS would work. But angle, side, side, I get it. Doesn't work. Can't use it in school, can't use it here. We got a whole reason why it worked. Just trust us. These two do not work. Don't believe us? We'll show you. All right. So we know why the other ones work. We said side, side, side works. I'm going to draw a triangle right here. You won't use it as a joke. You'll never use it. So just think you'll never ever use that. If you do, you're wrong. You're just trying to be wrong. All right, so we got a triangle here, right? We got this. So let's say we got this going up. All right? No, that's not going to work out. So I'll do that. All right, we got this triangle here. We got 90 degree, got a 45 degree, got a 45 degree. All right? Do we agree that's a triangle? Cool. It's a triangle. Where's my group? Group? Group. All right, so we got this, right? If I copy this over, if you notice, the sides match up. That side, this side, this side, this side, this side. Do we agree that these triangles are congruent? Are these triangles congruent? I just copy it. It better be congruent. It's the exact copy of it, right? Notice the angles. 45, 45, 90, 45, 45, 90. This works because if the sides are all congruent, then the triangles are congruent to one another. Watch what happens now. Are these sides congruent still? The sides are congruent? You're telling me that side's the same length as that side. They're not, but look at the angles. Did the angles change? The angles stay exactly the same. That's why angle doesn't work out, because the shape can change, but the angles remain the same. Another example is this. Imagine an equilateral triangle in your head. All the angles are 60 degrees in equilateral triangle, right? If I have the world's smallest equilateral triangle versus the world's largest equilateral triangle, the angles are still 60. Angles doesn't matter. The sides will change at that point. Because we can't predict that they're always the same, the first example I did, they were the same. But if you're like this, they're not the same. So angle, angle, angle does not always work out. Therefore, that's why we can't use angle, 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 or angle, side, side. They will change. Questions on that? Never use those two. All right, let's go on to these ones. Now, you have all those. You have those four little postulates you can use. So you're going to tell me, based on what we have up here, are these triangles congruent to one another? Let's look at number A up here. So I like to start with the left triangle. It doesn't matter where you start. And we're going to see if it's the exact triangle, if these triangles are congruent to one another. So I'm going to start here. I just pick a random point, the furthest one, and I got to work my way around the triangle to determine what piece I have. So I start at this angle. I got to work my way around. Notice I can't go from T to N because there's no side right there to like move across like a little bridge, or there's no angle at N. So I have to go this way. See, I go from T to that tick mark right there to the Y. That works out. If you go around, you'll notice I start at an angle, I go to a side, and I go to an angle. So angle, side, angle. So for this to be congruent, I have to have that same pattern on the other side. So notice I went from 2 arcs, 1 tick mark, 1 arc. Okay, let's go there. So I started at the 2 arcs over here. I start there. I got to go this way because it tells me to go to 1 arc next, right? Then I have to go to that 1 tick mark, which is way up there. But the problem is I can't get there because there's no angle right here. So these are not in the same location. We realize that these are the same marks. Notice there's 1 arc there, 2 arcs there, 1 tick mark there, but they're not in the same spot. This picture is saying that TY is the same measure of SJ. Are those the same measures? No, they're not. They're not in the same order, so there's no way that they can be congruent to one another. So this is not congruent. Let's look over it. Letter B. Well, when we do this, we have these things, we call them shortcuts. There's a way to, so we don't have to prove, well, I guess you don't know the other one, but they're shortcuts, what these are. How many pieces, again, think how many letters, how long these letters are. How many pieces do we need to prove these shortcuts are true? How long are these letters? How many letters are in these little phrases? 3. So we need 3 pieces to prove these triangles are congruent. If I just look at one of these triangles, okay, I'll look at the top one for right now. My shadow doesn't cover it. If I look at this one, I only have 2 pieces marked. I've got an arc and a side. So I don't have enough. But this is a special type of triangle we learned the other day. Bow tie. What do bow ties always have? Bow ties always have this type of angle in them. Starts with a cute, it may be good looking, I don't know. Starts with a V. Vertical. Vertical angles are always inside bow ties. So it's one of the freebies. You see a bow tie, boom. You know, vertical angles is one of the reasons. There we go. Now I've got those three pieces I have. Let's see if they match up in the right order. So I'm going to go over to one of the furthest ones. I'm going to go this one right here. So I've got an angle. Got to work my way around. Can't go this way because there's no side or angle. So I have to work that way to the green arc. So I go angle, angle, side. So the one triangle is angle, angle, side. We want to see if it's the same in the other one. So I went from one arc to two ticks. One arc going around to two arcs to two tick marks. So are these congruent to one another? Are the pieces the same in the same order? Yes. So what reason makes these congruent? And guess what piece you found? I had an angle, and a side. So my reason is angle, angle, side. These are congruent because of angle, angle, side. What about letter C? Are these triangles congruent? And if so, why? Oh, love that. Yeah, you see shared triangle. He's saying it's reflective. I'm going to go ahead and mark that, as you should mark it, knowing that they're sharing a side, they will be congruent to one another. So that may help you solve this. How, if at all, are these triangles congruent? What pieces do they have in common? What do you say? D and B is shared, yeah. But I'm saying, side, 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 angle, side, angle, 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 side. Which ones do they have? What do you say? Side, angle, side. Let's figure out which side are you looking at. Just pick one triangle. 4, the one tick mark, or the 2. 4. Number 4. So you go from side, angle, side. So you went from 4 to the one angle to the one arc. See if it's the same as the other one. 4 to the one arc to the one side. That works. Side, angle, side works. Does somebody else have something different? What? Who? Angle side. Where are we looking at that at? Starting at E. The tick mark. So angle, side, and then you went over here, right? I'm assuming. So one arc, one tick mark, 3 arcs. Do the same over here. One arc, one tick mark. Okay, yeah, I like that. So you said angle, side, angle. Did someone have something different? You guys are just following along with the other classmates. I'll write down what they write down. If I put banana down, you write banana down. Come on, you guys. Nothing else? What about the sides? Are all the sides marked in this triangle? DAB, dab? A 4, a 1, and a 2? Are they marked in the other one the same exact way? A 4, a 1, and 2. So won't side, side, side work? Oh, the sides are marked. And there's one more that's going to work. I can go anywhere, it doesn't matter. But look, I'll go from 1 arc to 3 arcs to 2 tick marks. Angle, angle, side. Same thing up here. Angle, angle, side. Wait a second. All 4 work? Yes, they do. Does anyone know why all 4 work? What is different about C compared to everyone else on the page up there? What do you say? Yeah, it's a rhombus shape. Yeah, I don't know what necessarily it is. Could be some sort of parallelogram, but yes, that's part of what it is. It could be it. Doesn't necessarily have to look like that to be that reason. Yes? Yeah, they're shared that side. That could be it there. Well, here's the biggest thing. Are any of the sides marked over here in B, other than these two right here? Are all the sides marked? Are all the angles marked? No, I don't know what these 2 angles are. Notice over here, everything's marked. If all the pieces are marked, then you know all the pieces that correspond to the same part match up. So that's why this one all works out. Everything's marked, and everything matches up, so it's good. That's why all 4 of those work. Last one, D. Are these guys congruent? Are these congruent?
Yes.
Yes! Way to shade out the answer. Now why? Of those 4 reasons, here you go, look at them. Okay, hold on. Where's the side located at? Do you have any sides that are marked? Whoops. Oh! You're calling AAA is what you're telling me. Whoa. Yeah, it is a company. You can't call AAA. Remember I showed you that big equilateral triangle and the big equilateral triangle. They're not going to be congruent. No sides are marked, correct? All the angles are marked, and we can't do that. So because there's no sides marked, we can't prove it. So we don't know for sure that these are congruent. So these are not congruent. It looks really good. I bet if you traced it and you put it over top of it, it would be. Huh, but it's not. Can't do it. Can't prove it. It may be, may not be. Could be a centimeter off. There you go. Like those? They're easy. Just work around the pattern. No, you have to like them. All right, this next one. Skipping this one. Don't look at that one. Look at this guy. So skip the next one, that bow tie. Let's go on to this next one. So we're getting better at these. I know your confidence. I can see it soaring through the ceiling right now. There's at least 3 things, if not more, that we know. Everyone in here should know those 3 things. And you should be filling those 3 things in right now. Because I know what you're thinking. You're thinking that the first statement is always your given statement. So I'm going to write that statement up there. Angle D is congruent to angle F, and GE, General Electric, bisects, I'm going to abbreviate here, guys, if you can handle that, angle def. That's given to you. You better write that down. What's always the reason for that first statement? It's given to you, so you need to write given. One more freebie, for sure. Everyone should get, even if you're just said to get the motions. Okay, what we got? The proof thing. Don't write the word prove. Write this. So DG is congruent to FG. That's it. And I know 5, the reason over 5 over here is going to be one of those 4 shortcuts. So if you were just going to take a guess, you got a 1 in 4 chance of guessing it right now. No, I guess not. We'll talk about that one in a second. So let's go on here. Is there anything else based on this I could get? You see anything in the given that could help me out and I can use as a reason? What? It's a word, right? So what's going to be the reason when I see one of those words? Definition of. Now bisector is a little weird one. Definition of. What kind of bisector is this? What is being bisected? A segment or an angle? An angle. So this is definition of angle bisector. Great. That works out for me. Anything else that I could do without really doing this in the problem? See anything else special about these triangles? We haven't seen one like this, but it is doing something that you may be familiar with. Yes? You already said GE bisects. Oh, you're saying this other angle over here? DGF? We don't know that. Okay, we know that other one for sure, but we don't know because we don't know about these legs there. Not a bad guess. Anything else based on the picture? Something special about these aren't bow ties, but there's something else going on in here. Notice their locations to one another. What's congruent? What side? Yes, what do we call that? When we have these types of triangles, what do we call it? They're touching each other. They're sharing a side. What's that property when we always have shared side? When you look in a mirror. It's reflexive. So whenever you have a shared side, you know it's always reflexive. So right now, this is out of 10 points, you have 5. You have 50% with just writing down those 3 things you know, knowing we have a vocab word, and knowing these triangles are touching each other. Pretty straightforward. Now, let's start marking what we know. We always have to have our picture. We have to make sure we mark it because we need those 3 pieces in order to prove these are congruent. So D and F are congruent. Already marked for me. GE bisects DEF. What's the meaning of bisect? Split two. So I can say that this big angle is being split into two angles. This little guy right here and this little guy right here. Because they're split in two, what do I know about their values? They're the same. So I'm going to say something that saying they're the same. I'm going to say, I'll name it first and you guys name the other one. I'm going to say DEG. So angle DEG is congruent to what other angle? We just bisected half, so I said the top one up here. What's another one at the bottom we call? Order matters. Be careful. FEG. I went from one arc to two arc to nothing, one arc to two arc, nothing. So FEG is the other one. Angle FEG. Got it. Marked it. The next one says it's reflexive. Well, we already did this. We know it's sharing that side. So I can say that this side, I don't like that, this side is congruent to that side. Because how the triangles are oriented, they're kind of like butted up against one another. It's not twisted and making a weird parallelogram of some sort. So I can just say that GE is congruent to GE. They're the same. And it's reflexive. Now just look at one of the triangles. I'll look at the top one so my shadow's get away. I've got three pieces. 1, 2, 3. What three pieces do I have? Angle. So try angle, angle, side. So do I have that in the bottom one? Angle, and I do. So are these triangles officially congruent? Yes. And we need to state that. Perfect. So I can now say the triangle is congruent. How do I name the triangles? Some of you guys are terrible at it, so it's real easy. You already named an angle once up here. Just call it a triangle now, keeping it the same. So DEG is congruent to triangle FEG. And what was that shortcut you told me? Perfect. Angle, angle, side. Now normally we would have been done. Every proof you've had up until this point stops with saying triangles are congruent. Don't believe me? Look right here. Triangles are congruent. Going back, all the other ones. Triangles are congruent. I mean, we'll go on for days, and you'll do triangles congruent. But now, in this problem, we're not asking if triangles are congruent. We're asking if a piece is congruent. And this is going to go in your toolbox. As soon as you see that proof is saying that something is not, it's not saying triangles are congruent, if it's saying a piece or an angle are congruent, the reason is always this reason. You haven't learned it yet, so hopefully you're prepared for this. Ready? CPCTC. You just sit there, what? CPCTC. CPCTC. You think I'm making it up? That's a real thing. Now you're asking what CPCTC stand for. You look back in your eyes, I love that. Yes, what is it? And you thought I made that up. It's in your notes. I don't make these things up. What that really stands for is this. Once you know the triangle is congruent, don't you know all their pieces are congruent? If I prove they are, then it stands for the corresponding parts of congruent triangles are congruent. Yes, you have to write that down. If you're going to say, how do I remember CPCTC? A lot of C's, a lot of P's and T's in there, right? So there was a book that Miss Golini wrote back in the day, and she came up with this phrase. Cool people count their coins. If you remember cool people count their coins, you'll remember the CPCTC. Now there's a book out there, I want to warn you about it. You read it. Doesn't quite go with her statement there. It does not go with this, but some people like this way better. CPCTC, crazy people cook their cats. I wouldn't recommend it, but let's just count your coins, everybody. Cool people count their coins. You'll have that remembered. All right? Questions with that one? Again, we'll get much better, but you'll see the patterns. Really, you could have got 7 of the 10 without doing any work. Just follow the pattern.
5 minutes. Maybe we can get through this one in 5 minutes.
Probably.
All right. Go back to this one. We know those tricks, so this one should not take us that long. Again, our first statement of reason every single time is the given. So L is the midpoint of WE, and WR is parallel to ED, and that's given. We're trying to prove, again, that's our last statement, that these two triangles are congruent. That means we are either going to use angle, angle, side, angle, side, angle, side, 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 side. One of those. We're not using CP, CTC when you're proving triangles. Okay? Keep that in mind. Go to your given information. It's saying L is the midpoint of WE. What does it mean to be a midpoint? It's directly where? The midpoint is in the middle. So then what do we know our reason is going to be for number 2? Definition of midpoint. We have a vocab word. We know our reason is going to be definition of that vocab word. And think about, again, we said L is in the middle. So what do we know about WL and EL if it's directly in the middle? Congruent. So that's what you're going to say for your statement. We're going to say WL is congruent to EL. And again, order matters. We went from out to in, so we have to go from out to in. Took care of that bit of information. Now it said that WR is parallel to ED. What did we say yesterday when we were given parallel lines? What's our reason going to be? As if it's sharing side. I'm going to check. Think about the type of angles with parallel lines. I have to flip back to what we did yesterday. We have parallel lines. What did we say the reason was? What kind of angles? They're inside. Good. Alternate interior. Every time you have parallel lines, your reason is going to be alternate interior angles are congruent. Okay, I'm going to highlight our parallel lines to kind of extend them. And this side, and it doesn't matter when it's these type of triangles, you can pick any line, but that was acting as our transversal. The alternate interior angles have to touch both of those lines. So I'll state one of them. W is touching that yellow and green line. What's the other alternate interior angle? Yeah, E. It's touching both lines. So we can say angle W is congruent to angle E because they're alternate interior angles. You could have also done R is congruent to D. In this case, it doesn't matter which angle. Just pick one. All right, we took care of that given information. Now look and see. What type of triangles are these? We should be talking about bow tie. What do we say we have with bow tie triangles? What kind of angles? What? They are congruent. Start with a V. Vertical. So we know vertical angles are congruent. And you just have to state what those vertical angles are, which is RLW is congruent to angle DLE if you go in order. And your reason is angle, side. Because we marked that these are congruent. Oh, sorry, angle, side, angle.
Well, we got one now. Picture goes back to the same locale.
Angle, side, angle. I'm just writing stuff down. Thank you for saying.